Now what we're going to do is we're going to solve exponential equations. When we're solving exponential equations, the first thing that we're going to do is look for a common base. So if we're looking at the example already done, we see a 2 and an 8. These are different bases. So our first step is always to make sure that we have common bases. And the reason why is because when we have common bases, they cancel. And we're left with a linear equation, 3x equals 3, which of course x equals 1. So that's our goal. For the first example, what we have is 3 to the x equals 27. So our first step is to find a common base. So 3x stays. And instead of 27, I'm going to put 3 to the third because 3 to the third is equal to 27. And then the 3's cancel and x is equal to 3. For the next one, we need a common base. Our common base is going to be 2. So we keep the 2x plus 5. And 16 is 2 to the fourth power. So since we have a common base, they cancel. And we have x plus 5 equals 4. We subtract the 5. And we get x is equal to negative 1. For the next one, same thing. We need a common base. We see 9 and 3, so our common base is going to be 3. So instead of a 9, I'm putting a 3 squared, and then I have a 2x minus 1, and then 3, and then x minus 5. The 3's cancel, and then 2 times 2 is 4, so 4x minus 2 equals x minus 5. We're going to subtract the x. That gives us 3x minus 2 is equal to negative 5. We're going to add the 2, and that gives us 3x is equal to 3. And then what we're going to do is we're going to divide it, negative 3. Then we're going to divide it by 3, and x is equal to negative 1. Now, not all the problems are possible. Sometimes we can't get a number that has a common base, so 5 and 55. They both have a 5, but we know that 5 to the 1 is 5, and 5 squared is 25, and 5 cubed is 125. So there's not a whole number that goes into 55. Now, next unit, we're going to learn about logarithms, and we'll be able to solve these problems. But for right now, we're going to say not possible. Now, looking at the next one. For letter E, once again, we need a common base. 7 to the x equals 7 squared. 7's cancel. X is equal to 2. For the next one, we need a common base. So we have 2 to the 2x. And then what we have is 2 to the 6th, gives us 64. 2's cancel. 2x is equal to 6. So x is equal to 3. Letter G is a difficult one because 4 squared is 16, not 8. So our common base is not going to be 4. It's actually going to be 2. So 2 squared gives us the 4. And then what we have is the x plus 8. Then 2 cubed gives us the 8. And then we have the x plus 1. The 2's cancel. We distribute the 2 to each of the terms. So that gives us 2x plus 16 equals, and then we distribute the 3, and that gives us 3x plus 3. We're going to subtract the 2x, and that right there gives us an x. And then we're going to subtract the 3, and that gives us x is equal to 13. Now, letter F looks like it doesn't work, but 1 is really the same thing as 8 to the 0, because anything to the 0 power is 1. So we have a common base, 3x equals 0, so x is equal to 0.